Now, as usual, now that we're happy with the way our code works with Python 2, let's go ahead and try to get it to work with Python 3. Now, before we get into this, I just want to highlight one very important fact. For this program especially, it really doesn't matter what version of Python it works with, because in the next section, you're going to learn how to compile this code so that it runs on any machine, even if it does not have a Python interpreter. Because in a real life scenario, you can't really ask your target to go ahead and install Python before you run the program. Therefore, the Python version is irrelevant, because at the end, the program we have here will actually be converted to an executable that runs on any computer. But anyway, for the sake of completion, I just wanted to spend one lecture to show you how we can get this code to work with Python 3, and you will see it is very, very simple, and it is very similar to what we have been doing with the Python 3 compatibility lectures. All you have to do is solve the conflicts between strings and byte objects. So, as usual, I have my code here that works perfectly with Python 2, and I'm going to go to my terminal straight away, and I'm just going to run it with Python 3. Next, I'm going to go to the target computer, and I have my code here that works fine with Python 2 again, but this time we're going to run it with Python 3. So you want to make sure you first of all download and install Python 3 for Windows, because previously we downloaded Python 2.7. So right now I have Python 3 downloaded, and I have the executable, the interpreter, installed in this path. So first of all, I'm calling the location where the Python 3.8 is installed, followed by the Python file that I want to run, which is this one right here, the reverse backdoor. And I know this only works on Python 2, so I'm expecting it to break. So we're going to hit enter. And straight away, as you can see, we have an error here. And if we go back to the listener, again, we also have an error here. So let's tackle the listener error first. As you can see, the first problem we have is on line 48, and it's because we are using raw input. Now, we covered this previously, and we mentioned that if you want to use raw input in Python 3, you should use input instead of raw input. So this is going to be a very simple one. We're simply going to go to line 48. So it's going to be here, and we're going to just remove the raw so that it just says input in here. So that's perfect. Now let's go to the error that we got at the reverse backdoor. And as you can see, this error is in line 47, and it is complaining, saying that we are trying to concatenate a string with a byte. So let's go to this line first of all, line 23. So this is the line right here, and the problem is this right here is a string JSON data, because we defined it in here to be an empty string, and we're trying to concatenate it with a byte object, because this method right here returns a byte object. Now to solve this, we either have to convert this to a string or convert this to a byte. Now, it's much easier to simply convert this to a byte, because we just initialize it here to an empty string. And to convert this to a byte, all we have to do is just type B before this empty string. We also covered this in a previous assignment. If you don't remember this, please go back and revise it. So we're going to save this. And this reliable receive method is also used in my listener, and I will probably face the same problem in the listener because we're also running it with Python 3. So it makes sense to just go ahead and look for this method. So it's the reliable receive, we have it right here, and convert this JSON data to a byte object as well by typing a B before the double quotes. So we're saving this as well. We're gonna go back, clear the screen, and run it again. We're gonna go to Windows, open our command prompt, clear the screen, and run the command again. Now, let's go here, and perfect. Now we actually managed to get a connection. So let's go ahead and try to execute a simple system command, and we're just going to do dir. So something crashed. It's telling us that there is an error during command execution, but we don't know what went wrong. And the reason for this is the code that we actually implemented in our last lecture. So if I fold this, so what we did is we used a try block to try to do all of this. And if anything fails, so we said except exception, if we get any exception, I want you to print this error message. So this is great when we're using the program in production, but now because we are debugging it, we want to see what's going wrong. It's really bad because we can't see exactly where the code is failing. Therefore, I'm actually going to comment these lines, the except lines, and I'm also going to comment the try line, and I will have to bring all of this back one tab behind because we're not using the try anymore. So it needs to fall in line with the while inside the while loop here. We're going to save the code, go back, Control C out of this, and run it again. And in Windows again, Control C, and let's clear the screen and run it again. And I misspelled that because I have the CLS at the end. So that's working now. And again, we have our connection. Let's go ahead and run a simple command again. And perfect, we fail again, but at least this time we're able to see where the problem is. Whereas previously, all we did is see a generic error message. So right now we know that we are failing at line 17. And again, that's because the send method in here expects a byte-like object, not a string, which is what it's getting. So very simple. We're going to go to line 17. This line right here. And this is the method. It's getting a string and it wants this to be a byte object. Now we know how to do this now. We've done it a number of times. If we want to convert a string to a byte object, we just do .encode. And that's it. So again, we're going to go down, clear the screen, run the code, Control C out of this, clear the screen, run the code. And now let's go ahead and again try to run a simple system command. Now this time it seems like it worked here and it probably broke here, and it did. And again, if we look where it broke, again it broke at the reliable send method at line 16. And the problem is it does not want a bytes object in there. So again, let's go here, go to line 16. This is the line that we have. So right here, the data is of type bytes, and dump S does not want it to be of type bytes. So if we trace this back, we run the command dir. So it got executed by execute system command, and that got the value of that got stored in our command result. The command result was sent to the reliable send, and the reliable send caused this issue. So tracing this back to here, it's the execute system command method that is returning a variable of type bytes that the reliable send is not able to handle. Therefore, to fix this, we just have to convert this to a string variable. So we're just going to do .decode. Okay, so that's done. Now let's Control S to save this and open up our terminal here, clear the screen, and we're going to go to Kali, Control C, run the program again. And let's run it here again one more time. And we're going to execute a simple system command. It's going to get stuck. We'll read the error here. And this time the error is in line 17, not 16. And this time it's saying a byte-like object is required, not a string. For which method? For the send method. So let's look at line 17. We see the send method here. We see the variable that is passed to it, and it's telling us that it needs a byte object in here, not a string. So to convert this to a byte object, as we know, we just do the .encode. And again, because the reliable send is also used in my backdoor, I'm actually going to modify it in here, and I'm going to convert this. Oh, and we already have done that already. So perfect. We should have done that before. So we're going to Control C out of this, clear the screen, run the backdoor, go back here, open the command prompt, clear the screen, and run the backdoor. Now let's execute a simple system command. And perfect. Finally, the system command get executed as expected. So that's really, really good. Now let's try to do something else. Let's see if we can get our current working directory by doing cd. And that works fine. Perfect. Now let's try to navigate somewhere else. So we're going to do cd ... And it says it's changing its working directory. Let's see if that actually worked. We'll do cd again to see. And perfect, that worked. Now let's go back to my downloads. And let's try to read a big file. So we're going to do more sample.txt. And perfect, we see the full file all the way down to the end. So our serialization is working fine. Now I forgot what files I have, so I'll do dir again. And again, I get all the files. And let's go ahead and test the download method. So we're going to do download gtr.jpg. Now, before I download it, going to the working directory of my backdoor, you can see that it is empty. And if we click here and hit enter, you'll see we get stuck. So the download didn't work. Let's go back here, see if we get any errors. And sure enough, we did get an error. And if we read the error is happening at line 16. Again, in the reliable send. And the problem is we're getting an object of type bytes, and therefore JSON is not able to process it. Now this happened when we used the download method. So let's go here and see what happens when we use the download method. So if our command is equal to download, we're going to use a method called read file. And if we look at the code for read file, it'll return the value returned by this method. So the value returned by this method must be bytes, because that's what the complaint is in here. So all we have to do is, like we did here with the command result when we used the execute system command method, this time when we use the read file method, we have to again decode this value to convert it from bytes to a string. Perfect. So we're going to Control C, open up the terminal, clear the screen, and let's Control C out of this, clear the screen, run the backdoor, and run it here. And I'm not going to test everything. We're just going to do dir, and then we're going to try to download my GTR again. And this time it says download successful, so that's really good. Let's go and see if it actually got downloaded. And perfect, we have the picture right here. So what I want to test next is the upload method. So I'm going to go to the Windows machine, and I'm going to manually delete the GTR image. And we're going to try to upload it now from my backdoor. So I'm just going to do upload gtr.exe. And this time we crash in the listener instead of the backdoor. And if we read the code, you will see that I tried to upload a file that doesn't exist. So that's completely my mistake. We're gonna run the code again and run it here. And this time, hopefully I will spell it right. So we're gonna do upload gtr.jpg. Upload successful. Let's go to the Windows machine and see if we actually have that file. And perfect, we have the GTR file. And now let's just test the other features that we tested at the start, just to make sure that the changes we made didn't break anything. So we're just going to do a quick dir, quick cd, cd ... to go back, cd to see where we are, cd downloads again, and let's read the file. And perfect. As you can see, the backdoor is running perfectly with Python 3, and we're able to read files, upload, download, execute, and do everything that we were able to do with Python 2. And again, if you think of it, all we had to do is simply solve conflicts between strings and byte objects, and we did this by simply using the encode method, the decode method, and by using the bytes in here sometimes to convert a string to a byte object.